Alright, ladies and gentlemen, welcome to the video notes for Chapter 3, Section 1 of your geometry textbook. We are going to do Chapter 3 a little bit differently this year. Sections 1, 2, and 5 are going to be 1 microunit, and Sections 3 and 4 will be done at a different point in time. So, this will be the first of several videos for Section 3-1, which covers vocabulary. A vast majority of this vocabulary is vocabulary that we should already know. So we start off as we always do. We're going to front load some vocabulary. Here we have 3 vocabulary words that we're going to put in place. 2 of them are based on a word that you should already know, parallel. The third is a new term. So, parallel lines. From your previous experience in algebra or pre-algebra, you know that those are lines that do not intersect. However, in geometry, we are not dealing with only 2 dimensions. We're actually dealing with space, which is 3-dimensional. So we need to add a qualifier to that. Parallel lines are, in fact, coplanar lines that do not intersect. So they are lines that are contained in a plane that do not intersect. Now, there are other ways, other than being contained in a plane, that 2 lines could not intersect. That is where skew comes in. Skew lines are lines which are non-coplanar and do not intersect. So these would be in 3 dimensions. There are examples that we will see here in a minute of lines that will never intersect but are not in the same plane. So they are clearly not parallel. And then finally, if we go up to 2-dimensional objects and talk about planes, it is also possible for planes to not intersect, in which case we would refer to those as parallel planes. There's 2 planes that do not intersect, 2 or more. So that's our new vocab. We're going to use that vocabulary first, and then we will advance on into the next part. So here we go. Here's our first example. In this picture here, we have a triangular prism, so we have to realize that this item is supposed to be 3-dimensional. We have the bottom is shaded in, so it's sitting on its base, as it were. And those dotted lines are edges that we cannot see because they're blocked by the shape. So you have to see this as being a 3-dimensional object. So the first question here asks us to name all line segments that are parallel to JP. So if we look at our picture here, JP is a vertical line segment connecting J to P. So there are 2 other line segments in this picture that are parallel to JP. LR is contained in the plane JPL along with JP, and it is parallel. So LR would be our first answer. You could also say RL. It doesn't make any difference which name you use. The other one that could be used as an answer here, and we have to be a little bit careful as I erase stuff here. Oh, see, that's why. Okay, the other stuff that we could use is back here on the back corner. KQ is also parallel to JP because it is coplanar in plane JPQ, and they are both vertical line segments, which means if we extended them, they would never intersect. So KQ is the other line segment that we could use here. You could also say QK, it makes no difference. So now we move on into skew, and we need to discuss, well, what is a skew line? And that's going to take a little bit. It's going to be a little bit hard to see because we've never seen it before. And in video format, you can't see my super awesome skills of making it make sense by showing you my arm movement. Okay? So, I'm sort of losing my picture a little bit here, so I got to clean it up a little bit. Give me a second. Alright, so we're talking about line segment KL. We're trying to find segments that are skew to KL. So KL is a top edge on this prism. We need to find other edges on this prism that never intersect with KL, but are not parallel to KL. So QR is the only line segment in this picture that is parallel to KL. So it's eliminated because it's parallel. There are several other line segments that intersect KL. Remember that skew lines are not parallel and do not intersect. So one example of a skew line would be JP. Notice that if I extend that edge forever, it still will never intersect KL because it will pass in front of KL. Okay, if we extended both of those line segments forever, it would simply pass in front. So JP is skew to KL. You could also say PJ. Another example of a skew line to KL would be PR. Once again, if we extended those forever, KL would pass over the top of PR, and PR would pass underneath. They would never intersect. They're not contained in the same plane. So PR is skew to KL. Finally, the last one that would work as an example of skew, for the same reason as PR, PQ is also skew. It passes underneath KL in 3 dimensions. Okay? That makes it skew. Never intersects, but at the same time, it never is contained in the same plane. So it's not parallel, it's skew. All right, moving on to our final question, a plane that is parallel to plane PQR. PQR is the shaded plane. It's the one on the bottom that is shaded in gray. Okay, here's PQR down here. It's the base. So we have to think to ourselves, which side of this prism would never intersect the bottom? The answer would be the top. So we need to name the plane that makes up the top of this prism, which would be plane JKL. There's another example on the next slide, so if you'd pause the video and try the next example in your notes, and then resume the video and we'll go through the answers. Thank you. Okay, so here is the next example here, and we're going to go through this rather quickly because you're supposed to have tried it on your own, so you should just be checking your answers. There are a total of 4 segments in this picture that are skewed to BC. They would be the 2 front vertical edges, AF and DE. Those 2 would pass in front of BC. They would not intersect BC. And then the 2 bottom edges that go from the front to the back, FG and EH. Those are both skew as well because they would pass underneath BC in 3 dimensions. On letter B, it asks us to name a segment that is parallel to EH. There are 3 of them in this picture that you could choose. FG is parallel, contained in the bottom of the shape. CD is parallel, contained in the side. And the third and final answer, which is actually kind of hard to see, is AB is also parallel. Even though that plane is not drawn, we could draw a plane that passes through this cube diagonally and would contain both AB and EH, and they still would not intersect, which would make them parallel. Letter C asks us to name all planes that are parallel to DCH. DCH is the right side, as we're looking at it, of this box. So the side that would not intersect would be the left side. So when you're naming that plane, you can use any combination of the 4 letters that make up the left side of the box, A, B, G, and F. Any combination of 3 of those 4 letters would be an acceptable answer. That does it for our first video. Our next video will cover vocabulary based on the idea of transversals. And then our final video will cover examples. So the next video will be the long one. Thank you for your time.